Hey everyone, thanks for coming to this workshop. This workshop is hosted by Usman Asim from Ava Labs, and he's going to be talking about how you can build your own blockchain on Avalanche. Before we get started, however, I want to thank our sponsors once again for supporting this hackathon and making everything possible. So thank you guys. The next thing I want to talk about is if you guys want to get in touch with us on any of the channels. So we have them all over here. You can take a screenshot, or we also have them in the YouTube description below. So you can reach out to us on Telegram if you have any questions. Usman and other DevRels are also in the Intersect group. So if you have any technical questions, you can ask them in the tech dev chat. The Dora Hacks is where you can sign up, and the website is where you can learn more about the hackathon itself. So with that, I think the thing we wanted to announce now is that the Pearl mini quests are live. So right now, all participants can start signing up and actually complete those mini quests to earn Pearl tokens. All you need to do is visit our Telegram, guild.xyz/intersect, and you can start winning tokens. The last thing I want to tell you guys is that the test set is actually live. So I know some of you guys had issues regarding how to start building. Well, the testnet and all its details are actually live on our resources page on the Dora hacks. And if you guys want Pearl testnet tokens to actually start building and navigate the testnet, just ask us on the Telegram and we'll send it to you on the address. So with that, I think I want to hand it over to Usman.
Amazing. Thanks so much, Azair, for the awesome intro. Um, yeah, my name is Usman Asim. I am one of the DevRel engineers here at Ava Labs. And we'll go ahead and get started here. Um, okay, let's see. Do you mind if I think if you stop sharing the screen, I can. Oh, perfect.
Yeah.
The,
Right.
for the awesome intro. Um, yeah, my name is Usman Asim. I am one of the.
Can you share the screen?
Yeah, just pulling it up here. Okay, perfect. You guys able to see that?
Yeah. Perfect.
Perfect. All right. So just to get things kicked off, yeah, again, my name is Usman. I'm one of the DevRel engineers here at Ava Labs. And today we're just going to be talking a little bit about the Avalanche network, about where we've been so far, where things are at today and where they're going, and then more broadly about the blockchain space in general. So don't worry if this is your first intro to the blockchain space, or you may not be super familiar, or if you are super familiar, this presentation is going to hit all the points for anyone at any level. So let's go ahead and get into it. So whenever I start off these conversations of Avalanche or just in general blockchain-based conversations, I always like to start off with this question, right? Regarding where has blockchain been until now? So when we talk about blockchain and we talk about this industry in general, uh, we should zoom back a bit and realize that blockchain, distributed systems, cryptography, all these concepts have actually been a huge part of computer science for many, many years, way before this industry even started on a professional setting. Um, a lot of these things were rooted in computer science for many, many years, and they were actually a lot of them were theory. That is until the great financial crisis in the US had occurred here in the 2008, where there was a huge financial crisis, and someone took this theory of a distributed network controlled by many different participants and decided, hey, what if we build a financial system on top of it? And that's where this idea of Bitcoin was born. I'm sure you guys are all familiar with Bitcoin. But this was the real first public implementation of a real blockchain that was fully distributed. So they took this concept of a database that is secured by thousands and thousands of computers, that's fully transparent, that's fully immutable, fully that no one can change, censorship resistant. And they said, let's build a currency on top of it that will separate us from this global financial system that just crashed. And it was awesome. It was a real showcase of this technology. It still, is. But it was a V1 of a new technology, right? They took theory and they put it into practice. And like any V1 of a new technology, it's going to be clunky, right? It's not going to be a smooth ride throughout the way. So as they realized with the first implementation of a real public blockchain, they realized that the concepts that they had utilized to create it had allowed it to be slow, wasn't really scalable, and there were other scaling problems with it. But this concept of a distributed network controlled by many different participants was very appealing to many who were interested in the space. And with that came this idea of Ethereum. Ethereum was another blockchain that was introduced not too long after the Bitcoin introduction. But Ethereum took a little bit of a different approach, and they decided that instead of just creating a currency or a single blockchain with pure financial goals, such as Bitcoin. They said, what if we take this concept of a distributed system and actually implement programmability on top of it, right? Where now instead of just having one currency attached to one network, you can actually create applications that are based upon multiple different assets and actually utilizing the benefits the blockchain technology provides you while building your own applications. So this was a huge new paradigm shift. This introduced concepts such as the Ethereum virtual machine, which you can think of as this world computer that everyone read and writes to. And it also introduced this idea of smart contracts, which are essentially programmable pieces of code that live on the blockchain. And these pieces of code can be auto-executable. They're fully transparent, where you can see the code of what each contract holds and things of that nature. And it was a really powerful shift. And it actually allowed for many new applications that weren't possible to be built before on the internet to be built now. Um, but again, as we mentioned before, like any V1 of a new technology, you're gonna see some clunks, right? And so realizing that once many different applications started to be built on this platform, and once there were a lot of different participants that were building within the network and building different applications, they realized that it wasn't really sustainable for uh, many different people to build applications in this way. So then came this era in the blockchain environment where you either had many new companies that were spinning up and either creating tooling surrounding existing things with Ethereum, like Chainlink, which was bringing on-chain data, which is bringing off-chain data to the blockchain. You have platforms like Polygon that were trying to create the scaling solution for Ethereum. So to that they had Ethereum in mind, and they said instead of creating a whole new platform to uh, separate ourselves, let's actually create a scaling solution for Ethereum. And then you had platforms like Solana and Near that basically launched their own virtual machines and their own paradigms and did something completely different than what Ethereum did, and built upon the principles, but did it in their own implementation. And last but not least, you had a platform like Avalanche, which took the vision that everyone is going to need their own blockchain one day. Um, and instead of having a single chain, single asset system like Bitcoin, or a single chain multi-asset system like Ethereum, that the world would be composed of multi-chain, multi-assets. And so that's kind of where we were at for a while. And this is kind of where we're at today. So I threw up this, a couple of graphics from the industry of many different companies of different ecosystems that live. And I'm sure for someone who's not too familiar with the industry, you're going to look at this and you're going to be like, wow, there are just so many different companies that are in the space. And this is kind of where we're at today, in the sense where um, there are so many new pieces of the industry that are being built constantly, whether that be, on the modular side, whether that be the layer twos or Bitcoin layer twos or whatever the case may be, right? And so it can get really confusing for someone who's new to step into this industry and say, "Wow, there's just so much to learn." Um, so that's why I always like to rewind a bit and really touch on the fundamental basis of what all these things mean. So let's rewind to what makes a blockchain really valuable to us. At the end of the day, what is a blockchain? A blockchain is just a database, right? A database that stores data in a way that's meant to be immutable, meaning that no one can change it. Some blockchains have the idea of full transparency, where you can read all the data that's been on the network since its inception. Um, but at the end of the day, what's really, really powerful about these blockchains is that they're being secured by thousands and thousands of computers all around the world, right? So instead of me, Google, Amazon, one company controlling the entire network, uh, this network is actually controlled by you. It's controlled by me. It's controlled by you. It's controlled by everyone who's running a computer that is validating that network. And that process of validation, that process of getting all these computers to agree upon information is called consensus. So consensus has been a part of computer science for many, many years. It's actually one of the concepts that we were discussing earlier in terms of distributed systems and things of that nature. And until now, there's been three major advancements of consensus. Classical consensus, which was introduced to us in computer science, Nakamoto consensus, which is introduced to us with the advent of Bitcoin, and then Avalanche consensus, which we're going to be delving into today. So when you look at these three advancements of consensus, you can look all the way back to the 1970s with where computer science was, being studied, and a lot of this blockchain-based stuff was purely theory, where classical consensus was a really powerful consensus mechanism and operated really, really efficiently. But the problem was that it wouldn't scale beyond 100 participants, right? Where you have all these efficient, verifications of data happening, but the problem is that it can only happen in a very concentrated amount of participants, right? So, um, if there were 10 of us in this room, getting us 10 to agree on information is much easier than getting 1,000 of us to agree on information, right? So that's kind of the concept of classical consensus. And then in 2008, 2009, when the idea of Bitcoin came to play, where, we want a fully distributed network that one person can control, that's validated by thousands and thousands of people, that's where Nakamoto consensus was introduced. So Nakamoto consensus does really, really well in terms of supporting many, many validators, many, many participants within a network. The only problem is that when you have so many participants in a network, thousands of people, let's say we had 10,000 people in one room, it's going to be very, very hard, and it's going to take a lot of time for all of us to agree on one piece of information. And that's kind of the way you can think about Nakamoto consensus, where it's a very scalable system, but it doesn't scale efficiently, right? So getting all those people to agree on information is actually very slow and can be very expensive. So in 2018, was the birth of Avalanche Consensus, which was pioneered by Dr. Eamon Goon-Siever, who is the founder and CEO of Ava Labs, was also a professor at Cornell University. And so two of his PhD students and himself went ahead and tried to tackle this problem. They said, how do we take the efficiency and powerfulness of classical consensus and combine it with the scalability of Nakamoto consensus? So we could have a consensus mechanism where we can scale to thousands and thousands and theoretically millions of network participants while still having super fast efficiency and not sacrificing on any efficiency when it comes to finalizing transactions or things of that nature. And that's where Avalanche Consensus was born. And so Avalanche Consensus powered this idea of near instant finality. Now, what is finality? When you talk about finality, you're talking about the speed of which transactions are confirmed and actually finalized on the network. So once a transaction is finalized, it can't be reversed or modified, right? So that's the whole value add of a blockchain, that once you put this piece of data on there, once a transaction has taken place, that transaction cannot be reversed, and it's fully censorship resistant and is fully immutable. And the problem is that when it takes a long time for, a transaction to be finalized, it could take, in Nakamoto consensus or in any other consensus protocol that isn't as efficient, there may be a lot of time from the minute that you send a transaction to the minute that that transaction is finalized on the network. And in that process, in between, like once it's here and it's finalized, no one can change it. Once it's sent, it's trying to get to this point, right? And in that in between process, many things can happen. A block may be included but then be removed, right? Some nefarious actor could prevent your transaction from being finalized. So this finality piece is really, really important when it comes to blockchain because if I click a tweet on a blockchain-based system, I want that tweet to be published ASAP, right? I don't want there to be some sort of delay where someone could look at that and change my information or prevent that from being published to the network. And so, despite the previous consensus mechanism, the Avalanche consensus had hit this breakthrough moment where you can have thousands and thousands of people who are all participating in the network, but you can actually also finalize your transactions in under 2 seconds. That means thousands and thousands of computers can all agree on information and publish it to the network in under 2 seconds. Now, that was a huge paradigm shift from what we had seen before in other blockchain-based systems. So you can think of the Avalanche consensus as well, actually, let me rewind a bit. These are some really cool graphics that showcase just the different visualizations of what it could look like on different platforms. So with Bitcoin, you can think of it as a single lane highway that takes a very, very long time to get across. Whereas Ethereum, you can view it as a multi-lane highway that has a shorter time to get across, but still significant amount of time. And then Avalanche Consensus you can view as a multi-lane highway that has a very, very short distance to get across. And so that was where the consensus mechanism was. Again, this is where Avalanche had begun, just the consensus layer, a theory layer of this computer science element. And then the idea was to build a blockchain-based network on top of it, right? When you have the fastest engine, when you have the fastest engine in the game, you build a car on top of it, right? And so that's exactly what we did, where the original vision of Avalanche was architected to be this network of networks, right? Where um, there were many different blockchains living underneath one umbrella that were all interconnected with one another, that all had their individual use cases and that were all separate from one another. And so that's what we, visioned this network of networks. And so um, I want you to remember this picture because we're going to be coming back to it a lot later in the presentation. But you can think of this as the way that the Avalanche network is originally architected, with the primary network in the middle, uh, and then everyone else's blockchains and validator sets being attached to them. So we started building out this middle portion initially, and we built out the Avalanche primary network. That primary network was actually composed of three different blockchains. So that's something that's really unique about Avalanche, where in one network that's living underneath the Avalanche umbrella, you can actually host one or many different blockchains. So in the primary network, we have three different blockchains. One that was purely set around coordinating all these validators and creating new blockchains that was called the P chain. We also had an exchange chain that was super highly optimized. And then this is the one that most people knew Avalanche for, which was our EVM smart contract chain. So what we did was we took the EVM, which we mentioned earlier, the Ethereum virtual machine, which is a super robust, super powerful world computer, and we took it and we put it on top of our engine, being Avalanche Consensus. And what that basically did was it showcased for the first time ever in an EVM environment where you could execute smart contracts and have them published and deployed under 2 seconds, right? Where you could execute transactions on top of a EVM based platform and finalize those transactions under 2 seconds. So we took the most powerful virtual machine that existed until that date, and we put it on top of our engine to make it the most fast and powerful version of the EVM that had existed until then. And so Again, talking about the C chain being a fork of the EVM, and because it was on top of Avalanche consensus, way higher speeds, way higher throughput, lower fees, and shorter transaction confirmation time. So on our EVM, and these metrics are from a few months ago. Uh, to date, that one EVM blockchain that we launched has seen over 484 million transactions, um, around 1 billion in TVL, and this is just current day numbers. It's been higher or lower at different points in time. 26 million active addresses and over 1,800 validators. So that is just one network that we've built on top of this overall, Avalanche blockchain. And with that, you can see that the C chain has surmounted a huge amount of compute, which is this gas that's being used per day. At its peak was, burning over 900 billion units of gas, which is essentially compute that it takes to execute transactions on the network. And from there, we realized that, hey, we have one chain and it works really well. Now we can start working on the original vision of what Avalanche was architected to be, which was a network of networks. So um, we introduced this idea of subnets, and that name is changing very soon, which is essentially just a subset of validators uh, from the overall validator set that are validating one or more blockchains underneath that umbrella. So essentially, you could think of this as launching your own blockchain network, right? Where you define your execution logic, you set what the fees look like on your blockchain, you manage your state, you handle the networking, so on and so forth. And then you would ask me, hey, Usman, why would I launch my own blockchain, right? Why would I launch my own blockchain when I could use the Avalanche C chain, when I could use all these existing blockchains that already exist? Well, when it comes to launching your own blockchain, the first and probably a very important piece of benefit that you get is this idea of independence, right? Where instead of being on a network that's super crowded or on a highway where many different blockchains or many different applications live and many different transactions are coming through, you can actually have your own highway, right? And so you could have your own highway that's geared towards all the transactions for your application or whatever applications that you hope to have on your blockchain, and they all live on your network. That basically means that obviously because there's less transactions taking place on that network and they're all geared towards your application, there's going to be lower latency, there's going to be higher transactions per second, and the costs are going to be significantly reduced. So you get your own independent network. That's a huge value add. But there are nowadays when when Avalanche was originally architected, this was the first of its kind of platform that offered this. Nowadays, you look and there's many different blockchain networks out there that allow you to kind of launch your own blockchain, right? Or launch your own network. And this is what really separates Avalanche from the rest of those platforms. And this is what really got me excited about Avalanche before I even joined the company. Um, it's this idea of full customizability. When you launch your own blockchain, when you launch your own network, you should be able to define everything about that network, right? Where it comes to do you want it to be a fully permissionless network where it's fully decentralized and no one controls it? Or do you want to launch a fully permissioned network, right? Where you can control exactly who participates. Do you want to set custom gas fee structures? Do you want to have a custom virtual machine, right? We talked about the EVM being one really powerful smart contract execution platform that you can plug and play. But we also allow the ability to launch, the Move VM, right? If you're a fan of Solana virtual machine, you could actually port over Solana virtual machine and run it on top of our consensus mechanism. Or you could build your own virtual machine, right? And so we really allow you to have full control of what your network looks like, which is really, really different than most other blockchain as a service platforms out there because they will either restrict you to a certain amount of validators. They will either say, hey, you can only build a permissionless network or you can only build a permissioned network, and you can only build with one virtual machine. So full customizability, really, really key benefit that you get with Avalanche. And this is just a bit of the layers of what that customizability can look like, where you have Avalanche consensus on the bottom, whatever execution virtual machine that you want in the middle, and then that will enable whatever smart contracts that you like in whatever language that you like. And that's why when you look at different blockchains or you look at different blockchain networks underneath the Avalanche umbrella, they can all actually look very, very different from each other, right? Where you have one subnet um, that actually looks very similar to the EVM, but then you have another blockchain underneath the Avalanche umbrella that looks completely different. And then you have another one that has actually a completely different virtual machine, right? So you can literally build whatever you want, however you want, using what tools you want. And that's a really, really big paradigm shift from platforms like Cosmos or platforms like Polkadot, which really restrict you in the way that you're allowed to build. And then, diving a little bit deeper into what we mean when we say VM customization, you can actually either create your own virtual machine or modify existing virtual machines that exist today. Um, and so this is kind of like a really cool graphic that showcases like, when you have many different blockchains that are all short in time to finality, it gives you a massive, massive combined throughput in a really, really efficient way. And so that's what the Avalanche network had originally started off with. And until now, we've seen like a huge proliferation of different companies coming into the space and trying to launch their own network, be that on the gaming side, be that on the financial side, as well as on the enterprise and institutional side. Because remember, when you offer real companies the ability to build the way that they want, with full customizability, they're going to be able to take that and run with it. Um, when you offer institutions and enterprises the ability to say, hey, you can build a fully public blockchain with all the infrastructure that you need, but have the ability to fully permission it and, KYC, AML, and you can meet all the legal regulatory requirements that you need, they get really excited. In the same way that if I tell a builder that you can build a fully decentralized network that no one controls, that is fully permissionless, they get really excited too, right? So you can have the best of both worlds if you really choose to. And then you can also, I'm sure everyone recognizes some names from this list, um, where each one of these companies that you see on this list has been working with Avalanche or working to launch their own blockchain in one way, shape, or form, right? So um, you can see things like loyalty networks or institutions or payments that are really big use cases for a lot of these platforms. And so this is kind of just a really cool video that showcases where we are today, right? So I just screen recorded this not too long ago of the transactions that are taking place on the Avalanche network right now, where sorry about that, you can actually see in live real time transactions just coming through from many different blockchains. This is not just one blockchain, but these are many different blockchains that are constantly running simultaneously, where transactions just literally pumping every little second. So it's a really cool visualization. I think it just showcases a little bit about how interesting it really is to have all these different blockchains that all live simultaneously underneath one umbrella, and they can all process transactions very simultaneously. And so this is kind of like that massive combined throughput that we were talking about. Um, but then, when you look here to the to the when you look at some of the metrics that have come from that, you can actually see that from you saw the visualization of all the different transactions coming in, and from that what we've seen is that one of the blockchains that lived underneath that umbrella has seen over 670 million transactions, right? That's actually more than the primary EVM chain, the C chain, in total, right? So the C chain has only seen 486 million transactions, whereas one blockchain underneath the Avalanche umbrella has seen over 670 million. So that just goes to show you that if you launch your own blockchain and it's very successful, it can actually see more success than the Avalanche primary network, right? And that's kind of exactly what we want to see. And then you can see other blockchains that have launched that have had similar success rates, where Step Network has over 115 million, Dexalot, which is a DeFi platform with their own blockchain, 82 million, and then so on and so forth. And that's really what Avalanche 1.0 was until now, right? Where we've had this idea of a network of networks, um, things that we've built, and we really propagated it until now with this idea of Avalanche 1.0. But when you really look at the future of Avalanche, right, going forward, um, well, actually, let me rewind a bit. This is the idea of Avalanche 1.0, right? And we've gotten there so far, right? Where we have all these different blockchains that are living underneath the umbrella. We have, all these different smart contract platforms, so on and so forth. But there are still a few key pieces that are preventing us from reaching that original vision that we talked about at the beginning of this platform, which is the idea of Avalanche 1.0. So one of those key pieces is an SDK that we've launched to build virtual machines, right? So going forward, we really view virtual machine development as a really key piece of blockchain uh, infrastructure and development going forward, where instead of developers, writing smart contracts to build their own platform or writing a smart contract on top of an existing blockchain, you can actually embed the logic for your application at the virtual machine layer, right? So now imagine if you built your DEX, right, with token swapping built into the virtual machine layer. And what that does is it basically gives you way more power for your blockchain because now all that logic is natively built for your blockchain. So Hyper SDK is built with this engine called Bricks, which, if you want to go deep into it, there's this paper that describes how it works. It's a super interesting, super technical topic. But essentially, what it is just adding fraud proofs, uh, account partitioning, nonce transactions, and transaction filtering that basically makes that the TPS on any blockchain that you build on a Hyper SDK super, super powerful. And what this means is 100K TPS isn't theoretical anymore. And I know for a lot of folks who are in this industry and they've seen, the things that have been present for a long time, that a lot of people will tell it's very powerful transaction numbers. They'll say, hey, 100K TPS here, 100K TPS there. But what you're really seeing is that these super powerful systems are taking place on one machine, right? Or on 1 to 5 computers, right? Where remember what we talked about, the most powerful thing about a blockchain is that it's being validated by thousands and thousands of computers, right? So our head of engineering actually did a test with a virtual machine that was built using the Hyper SDK, where he wanted to load test this virtual machine on a distributed network of 50 plus nodes, running many different cloud instances. So not just one computer in my basement, but instead 50 different computers running geographically, distributed over multiple different cloud providers, so AWS, GCP, so on and so forth. And you can see that what this is doing is that it is actually creating 10 million accounts at a rate of 15K TPS right off the bat. And then after those accounts are created, all those accounts will start sending transactions to one another until that reaches 100K TPS. So just go ahead and watch that take place. And you can see all these transactions are now coming in, and there's 100K TPS that it's hitting on a recurring basis. And so I know that that was a very, very short video and you couldn't really tell much what was going on there, but this actually occurred over the course of 5 days where the network was running all these transactions for a sustained period of 5 days, and able to really to handle that load on a distributed network, which is really powerful. So that was really the main test of one of the virtual machines that we've done using the Hyper SDK. And aside from that, we have a couple other really big changes that are coming up within the next couple of months. One of them being ACP 77, which we really view to be this merge moment for Avalanche, where we're going to be decoupling the validators from the primary network. So there's a couple of different roadblocks that has essentially prevented Avalanche 1.0 from really being realized. And again, like with any V1 of a new technology, there's going to be some roadblocks, right? So we saw all the success in terms of all the different blockchains that launched, but then we also saw some roadblocks, right, that prevented new people from launching blockchains as easy as we wanted them to launch them. So one of so ACP77 is essentially going to be a way for us to remove all those roadblocks that we view that are really preventing us from reaching mass blockchain adoption at scale. So we're going to be decoupling the validator sets, adding some new management systems, and adding some new fee mechanisms that basically make it really, really easy for you to launch your own blockchain super cheaply and super efficiently. And this is why we view it to be like that merge moment for Avalanche. And again, um, all these blockchains being launched underneath one umbrella is super powerful, super valuable. But if they can't all communicate with one another, there's a huge problem. So there's this concept of Avalanche warp messaging, which essentially is this native communication protocol that lives underneath the Avalanche umbrella that allows you to be able to transfer assets or data between different blockchains very natively and very easily. And so this is done by, using the BLS signatures of each validator. I'm not going to get too deep into the technicals of how it works, but you can kind of see a little bit here with the visualization of how, message signing can be taking place using warp messaging. And so on top of that cross-chain communication protocol, you can actually build any VM to VM communication on top of that. So we built one EVM to EVM implementation. You can build your own if you would like, or you can build a Move virtual machine to EVM communication. You can build Solana virtual machine, so on and so forth. But we built the EVM to standardize it so that everyone can utilize it. And this is just a little bit about how that flow would look, where you start off on whatever application that you're sending a transaction from. That will trigger the teleporter, precompile, which will send that to the AWM relayer, which will eventually trigger that onto the precompile of the destination chain that you're sending, and that will eventually end up on your cross-chain DApp. Now, I know that's a lot of technicals, but essentially what that does is for you as a user, I'm sending one transaction on one chain, and that transaction is being received on another chain in a very efficient and very powerful manner. And that's with all those things combined, with all those different pieces that we mentioned, Hyper SDK, ACP77, and cross-chain communication. Now that's what's really going to set this vision of Avalanche 1.0 to fruition. And I think we started off with this graphic, right? I hope you guys remembered it from the beginning of this presentation. Uh, Take another look at it. This is what we sketched out Avalanche should look like. If you look at the original Avalanche, talks and papers, this image is everywhere. And this is what it looks like today in real time, where you have the Avalanche primary network in the middle, and you have all these different validators that are validating their own individual blockchains on their own. And I'll take it one step further and showcase this really cool graphic, right? So this is what it looks like today. This is all the blockchains that live underneath the Avalanche umbrella on mainnet. So if you look here, this is what we had originally sketched it out to look like, and this is what it looks like in real life, in real time today. These are all mainnet blockchains that are all launched on the Avalanche umbrella. And if you go one step further, this is what all the Avalanche subnets look like on testnet, right? And this is really what we view the future of Avalanche to look like, where there's going to be so many different blockchains that are all living underneath this umbrella that all can communicate with each other and exchange assets with one another. And if you look closely enough, you can probably even see the Intersect subnet living underneath this umbrella on testnet as well. And so there's a lot of work that needs to be done to get from here to here, right? And so I'm not going to underplay that we are here today. Our goal is to get here. And a lot of that will happen through the work that we described today with ACP77, with cross-chain communication, so on and so forth. So we have a full roadmap. It's very detailed. You can view it on a lot of our social media platforms. And it really describes where we're going and the roadmap of how we view all these things to come into fruition. So that really does it for the majority of the talk. I really appreciate everyone for sticking through. If you have any if you want to, get into touch with the community, you can obviously go to our Discord or Telegram. But we really recommend folks who are really interested in the tech, especially for the purpose of this hackathon, to go into the Avalanche Academy, learn about how to deploy your own blockchain. You can a lot of the things that I discussed today, you'll be able to see them in great detail. So be sure to check that out. But otherwise, yeah, thanks so much for sticking around. If you want to connect with me personally, I threw up my Twitter on there and I threw up my personal Telegram as well, so you can go ahead and message me. But yeah, that really does it for the majority of this talk. Before I do finish off, though, I do want to give a quick shout out to the code base program. So just going to quickly stop sharing my screen here and uh, share with you guys this program that we have launched that I really want to offer specifically to builders in this hackathon. So Codebase is essentially this Web3 accelerator that we've launched at Ava Labs, where we're essentially creating, an incubator for new companies, for people who have interest in building their own Web3 startup, right? So if that's you, if you're someone who wants to build your own company, build your own startup, um, and you take this hackathon to try and build the first step of your idea, let me know, right? Because we want to be able to support you. We have all these different really cool, we just finished our first cohort. These are some of the folks that won that cohort. We had a pitch day and things of that nature. So it's a really powerful program. We really want to support builders who want to build their own company. And if you are someone who is doing that, please message me. Would love to support you as much as I can.
Awesome. Thank you, Usman. There's just one question in the group chat. Actually, there are two. If you could answer them, I think that would be great. In the Zoom chat. Yeah, yeah, oh, sorry. I think you're muted. Yeah, I think you can unmute yourself now.
Okay, perfect. Yeah, sorry, I just clicked the mute button, didn't realize it would unmute. But yeah, I saw that we have teleported to connect from C chain to the main chain. Do we have access to it for the hackathon? Yes, you do. So, um, Teleporter is live. You can utilize it today. And if you want to play around with it, right? Like if you want to get some resources and really get into the weeds with Teleporter, it's actually something that we really, really want devs to play around with. So if you're interested, please hit me up and play around with it, because I definitely want you to check it out. But go to the Avalanche Academy. It's academy.avex.network. And then if you come here, you'll be able to see that we have all these different courses that are super easily available to you. If you want to play around with Teleporter, just check out Avalanche Interchain Messaging. We have literally everything from concepts to deep dive into the tech to how to actually deploy it yourself. So definitely check that out. You'll be able to play around with Teleporter and deploy your own instance of it. How
Oh,
fast is the Avalanche ecosystem growing at the moment, and what do you expect to see within the next few years? Yeah, so it's a great question. So until now, like I mentioned in the presentation, we've seen many different companies, enterprises, and individual blockchains launch, right? So it's growing very fast. And what we've seen is that we have all these other people who are really, really interested in launching their own blockchain, but it's very tough for them, right? Because of those roadblocks that I envisioned, right? Right now, you kind of have to go to the Ava Labs team. There's a lot of, middleware between actually starting to launch your own blockchain and actually launching it, right? So with all these changes that we view coming into the ecosystem, we view all those barriers to entry to be removed, and we really view that at that point there's going to be a huge like proliferation of new blockchains that are launching underneath the Avalanche umbrella, and people are really going to view Avalanche as the primary place to launch your own blockchain. And that's really where I see us going. Obviously, there's a lot of work on the BD side that's taking place to make this a reality, and there's a lot of amazing enterprise and institutions that are playing around in the space, including STC Bahrain, right? Who is one of the key hosts of this hackathon. So, a lot of work is being done in that way, and we're in a great trajectory right now. But I view that once these changes take place, it's going to be like a huge, huge rocket moment, right? Like straight up to after like these changes are made. So really excited for that. I think once those technical roadblocks are removed, there's going to be a huge change in the ecosystem.
Okay. Does anyone else have any questions, or is that it? What What do you think SCC Bahrain should do to grow their network?
Yeah, I think they're doing to start off with, I think already doing great things in the sense that at the end of the day, all these blockchains are developer-based platforms. They are catered towards developers and catered towards building applications. Um, so running things like hackathons, running things that are built to support developers, super valuable, I would say, right? Because at the end of the day, we're all looking for developers and we're all trying to get developers to build really cool blockchain-based applications. So I think that first step of launching a hackathon, getting people to play around with their technology is super valuable. And then finding developers, finding people where they are, building use cases that are specific to that region, I think are going to be really important going forward for that team.
Amazing. All right. Thank you so much, Usman, for the really cool workshop. I actually learned a lot from it as well. Like I didn't know some of these things as well. So it was really cool. If we have any more questions, guys, you can just ping this in the Telegram group. And I'll make sure Usman gets them or someone else from Avalanche gets them. So thank you all for joining. I know some of you left already, but okay, great. And if you can find the recording for this whole workshop on our YouTube channel as well. So be sure to check that out. And